rational expressions are pretty much just two fractions, one divided into the other. Here's an example of one. I've got this a squared minus 16b squared over ab. Think of that as a fraction, divided by this fraction, a plus 4b over b. Remember though that when you divide with fractions, all we do really is to invert and to multiply by the second fraction. So that's what I'm going to ask you to do. So we will take a squared minus 16b squared over ab, and we'll multiply by this reciprocal, which will be b over a plus 4b. If you remember back to section 1 or 2, where we divided and multiplied rational expressions, just remember that you're expected to factor everything first before you can simplify. So it does happen that this numerator can be factored, and I'm going to go ahead and do that down here in the second step. This is the difference of squares. So I can write this as a minus 4b times a plus 4b over this ab, and then here I have b over a plus 4b. The rest cannot be factored, and do notice that I put parentheses around this binomial because nothing can come out of it other than to say that 1 could be its factor. But the nice thing is to notice that this binomial and this binomial are alike, and they can be reduced. One is on top and one is on the bottom. There is another factor here. Don't forget this means a times b. They're not connected and that you can't separate them, if you will. These factors here, b on the top and b on the bottom, can be removed as well. Our answer to this problem, while it's called a complex rational expression, it's really not all that difficult to do. You have to take these, invert the second fraction and multiply, factor and reduce if possible, and write your answer down. Here's an example of a complex rational expression where the first fraction, the one in the numerator, and the second fraction, the one in the denominator, are not already, if you will, added or subtracted. This one, I need to subtract the 2 over 3x before I can do this invert and multiply process. Same thing with this denominator's expression, x minus 4 over 9x. I have to do this process. So you have to do the addition and subtraction in the numerator and in the denominator before you can invert and multiply over here. But what you notice then is that this needs a common denominator of 3x. So the 1 has to be rewritten as a 3x over 3x. That is essentially 1 minus this 2 over 3x. And then downstairs in the denominator, I need a 9x downstairs with this x. I'll go ahead and write it like this. So I need to multiply the x by 9x over 9x to get that denominator, minus this 4 over 9x. Now I'm going to go ahead and carry it one more step over here. Right here I'll have 3x minus 2 in the numerator over the 3x. And right here, please notice that this right here is going to become 9x squared. So I'll have 9x squared minus 4 over that 9x. And now I'm ready to invert this fraction and multiply. So I will take the 3x minus 2 over that 3x. And I'm going to multiply by the reciprocal of this one. So the 9x will go upstairs. And downstairs is the 9x squared minus 4. Please notice that right now I'm going to write that in factored form. That's the difference of squares. So I'm going to write that as 3x plus 2 times 3x minus 2, because I see that that's going to be able to be simplified with this binomial up here. And now I'm going to go through that simplification process. So the 3x minus 2's will cancel out. Please notice that these x's will cancel out. And 3 goes into here once, and 3 goes into here 3 times. So what we're left with is in the numerator a 3, and in the denominator this 3x plus 2. As was before, with the case before, please don't try to simplify this right here. The 3x plus 2 is a term in a binomial. It cannot be simplified with this 3. Only if it could be factored, and you could get a factor of 3 out could you reduce it with the numerator.